Assalamu alaikum. So basically the paper I looked at is about bearing strength and failure behavior of bolted composite joints. The authors of this paper are Zion and Ishikawa. The paper basically focuses on a very practical issue in composite, how bolted joints behave when they are used in laminate structures. So the research carried out experimental tests on composite laminates with different stacking sequences. These included laminates rich in 0-degree piles, laminates with cross ply orientation like 0 by 90 symmetric, and angle ply laminates like plus minus 45-degree symmetric. These stacking sequences are considered thicker quasi-isotropic style layups such as 0-degree, plus minus 45-degree and 90-degree symmetric sequence. They loaded these bolted specimens in tension and observed the bearing strength and the failure modes. The bearing strength are about how much load the per unit hole area the laminate could carry, and the failure modes are observed mainly by shear out, net tension and bearing strength. They also checked how thickness and bolted feet influenced the strength. The main key findings were ply orientation and stacking sequences control strength. Failure modes depend on geometry and layup. Bolt fit mattered, and laminate thickness improved behavior. So basically, this paper is connected to my class lecture Macro Mechanics of Laminates. In this Macro Mechanics of Laminates, we basically discussed and learned about different laminate angles and their work. As the sequence of different laminates could change the strength, failure behavior and etc. of an composite material. In the class we learned about the properties of laminates depending on elastic module, and each elastic module, angle of orientation, stacking sequence and thickness of the composite. But when we use 0-degree piles, we know from the theory that stiffness in the load direction is maximum. Experimentally, those laminates showed the best bolted bearing strength in this paper. When cross ply and angle ply laminates were tested, the strength dropped, which matches the prediction from laminate stiffness calculation. Even the thickness effect can be linked to the ABD matrix we studied. A thicker laminate with symmetric stacking distribution loads better and resists certain brittle failures. So from this paper we can easily say that the stacking sequences of laminates are highly connected to composite materials, and the thickness affects the matrix failure behaviors. That's all. Thank you.